Welcome. So now we're going to solve for missing measures, first in squares, and then we'll review all of the different special parallelograms, rectangle, rhombus, and square. All right, so this is in your notes. Let's find some missing measures. Given ABCD is a square, complete the following. All right, so the first one tells us that AB is 10. And it asks us to find AD and DC. Well, something we know about a square is that all sides of a square are congruent because a square is a type of rhombus. So that means if AD equals 10, then, AB equals 10, then AD has to equal 10, and DC equals 10, and of course BC would also have to equal 10. All right, let's look at the next one. Now, I don't know that from one problem to the next, the information carries through. Matter of fact, the information for the next problem has nothing to do with the fact that on question 1, the sides of the square were 10. So I'm just going to erase that for question 2. If CE equals 5, then DE equals, all right, well, this is part of a diagonal. And something that we know about a parallelogram is that the diagonals are bisected. That means each diagonal is divided in half by the other diagonal. But this is not just that's true for parallelograms, but this isn't just parallelogram, this is a square. And we know in a square, the diagonals are congruent. So we know the diagonals are bisected, because it's a parallelogram. A square is a type of parallelogram. And I'm going to abbreviate that because I don't have enough space. I'm just going to abbreviate that as p-gram. And the diagonals are also congruent. So they are bisected and congruent because this square is a type of rectangle. So if the diagonals are bisected, it means that AE is also 5. If the diagonals are congruent, then all of these segments have to be 5. So the measure of DE is 5. Right? So you see, these are not too difficult to figure out so long as you know the features of a square. Measure of angle ABC. So we're looking for this angle here. Of course, something we know about a square, it has 4 congruent right angles. And that's because, like we said above, a square is a type of rectangle, and all rectangles have 4 right angles. So in the measure of angle ABC, that would be starts at A, goes through B, then goes to C, is 90 degrees. Measure of angle ACD. Right, so that would be A, C, D. Right, so we're looking for ACD is also angle 6. Right, so this angle right here. Right, so in addition to knowing that all of the angles are 90-degree angles, we also know that the diagonals bisect opposite angles in a square. And that's because a square is a type of rhombus. And every rhombus has the angles bisected, the opposite angles bisected by the diagonal. So if an angle is bisected, it means it's cut in half. So that means that angle 6, or angle ACD, is equal to half of 90 degrees, or 45 degrees. And so, by the way, is angle 5, and angle 4, and angle 3, and angle 2, and angle 1, and angle 8, and angle 7. Because all the angles are bisected, right? And so all of them are half of 90 degrees. Now let's look at the last one here. The measure of angle AED, that would be this angle right here. And we know something special about that angle. Right? So in a square, the diagonals are perpendicular. And that's because a square is a type of rhombus. Right? So all the diagonals in any rhombus, it doesn't have to have right angles like the square. So long as it has 4 congruent sides, it's going to have perpendicular diagonals. So there are things that you can know about a quadrilateral. If it has 4 congruent sides, it has to have perpendicular diagonals, and the diagonals have to bisect the angle. That's true all the time. Whether it's a rhombus or more specifically a square, those diagonals meet at right angles. Okay? And something important about that, and something that even if you don't ever plan to build a house or build anything, you might buy a house. So a good way that you can tell if the house is nice and square and sturdy is to look at the diagonals of the window. If the diagonals are congruent, that means those rectangles are right angles. And if the rectangles are right angles, if all those windows are meeting at right angles, it means the house isn't settling. If you check the diagonals of windows and they are not congruent, I would not buy that house, because that house is settling and it's going to give you nothing but financial problems. Just saying. All right, so because the diagonals are perpendicular, we know that it's a 90-degree angle, and the measure of angle AED is 90 degrees. All right, so these are all done. These ones were in your notes. I'm going to do some more that were not in your notes. You might want to take some notes because they'll help you do the homework. They were a whiteboard practice, but right now I'm not using them as a whiteboard practice, so I'm going to give you video. In the future, if I make a video and if I decide to use the whiteboard practices, you won't see this next part of the video coming up. But that's okay. All right, so tell whether each figure must be a rectangle, a rhombus, or a square based on the information given. Use the most specific name possible. All right, so we want to use the best name for each of the figures. Do not look at the fact that it looks like a square. That's just a diagram. Right? It is not drawn to scale. It's just holding the information. So the only thing you can consider is not what the diagram looks like, just what the information is. So in problem number 1 there, we see 4 right angles. The one thing we can know about a figure that has 4 right angles is that it is a rectangle. Right? So any quadrilateral that has 4 right angles must be a rectangle. If in addition to having 4 right angles, it has 4 congruents. Let's go to number 3. So number 1 was a rectangle because the figure has 4 right angles. These ones are actually pretty easy. The third one is a rhombus because it has 4 congruent sides. If a quadrilateral has both 4 congruent angles and 4 congruent sides, it's both a rectangle and a rhombus, and it's a square. Now these ones were easy because they're basically the most salient features of the rectangle and the rhombus. Right? I could have made this a little more tricky. Let me show you. So instead, let me grab a shape here, and we'll use that one. All right, that's our shape. I could have said this. All right, so I'm gonna. All right, I could have said that was a right angle, and that would also be a rhombus, because a rhombus not only has 4 congruent sides, but because it has 4 congruent sides, it has perpendicular diagonals. I could have also, I'm just going to use the same kind of square-looking shape, even though it's not necessarily a square. Oops. Well, it gave me the wrong thing got cloned there. Because this is just a model. All right, I'll just draw it. I was just going to clone it. Now I think it looks like a rectangle. That's because I can draw that. All All right, so now maybe I say this. Oops. Well, that's a terrible diagonal. There we go. So these are diagonals. All right, so now maybe I say that this is congruent, this is congruent, this is congruent, and then these are congruent, and these are congruent. So not only the opposite angle is congruent, so it's a parallelogram, but the opposite angles are bisected. That is also a rhombus. A quadrilateral where the diagonals bisect both pairs of opposite angles and the opposite angles are congruent has to be a rhombus. Those are the features of a rhombus. Let's look at how else could I have done it. A rectangle, well, I could have done this. And this is either probably going to look like a square or a rectangle, but I'm just doing this as a model. I could have also said this piece of information. So that means the diagonals are bisected. But one pair of diagonals bisected is not enough to prove that that would be a rectangle. Kite also has that feature. But if I say this one is also bisected, and not only are the diagonals bisected, but the diagonals are congruent, it has to be a rectangle. Right? Because only a rectangle has two bisected diagonals that are also congruent. The bisected diagonals, remember, was a way to prove it was parallelogram. A parallelogram with congruent diagonals is a rectangle. Right? So now how else could I have shown that this was a square? I could take anything that shows the figure is a rectangle. Ooh. Well, that's just awful. Anything that shows it's a rectangle, and anything that shows that the figure is I'll just take that one, is a rhombus, and if I put those together, the figure has to be a square. All right, so in this one, I like the diagonals. That's a nice one. So pretend that's a straight line. Oh, that's just so awful. All right, the middle of the board is just the hardest part of the board to do anything in, as you can see. Now, why do I have arrows? Well, ignore the fact that that looks like there's arrows. There we go. Now I've got sort of diagonals. I make this one a little shorter. All right. So now, if I said that these were all congruent, and that would be a rectangle, but I also said not only are the diagonals bisected and congruent, they are perpendicular. Well, that's a rhombus. So this would be enough information to say that our figure is a rhombus. All right. Actually, I need to fix something on the rhombus. I just realized that information there, this one is fine. This is the top one up here. That would be true also for the kite. The kite has perpendicular diagonals. I have to make sure I make this a parallelogram. So now that would be a rhombus. Sorry. Yeah, the information is true for a rhombus. It is not only true for a rhombus. So we have to make sure. So that's good actually to have one like that. Actually, for me to accidentally make a mistake there, because it's not enough when you're trying to prove a figure is a certain type of quadrilateral to have a feature. It has to be that feature proves it's that figure and only that figure. So if I just had the perpendicular diagonal, when I looked at that, I go, oh no, that's also a kite. Okay, so that wouldn't be a proof it's a rhombus. If it'll also be somebody else. But if I make the diagonals bisected, okay, well now that's a parallelogram with perpendicular diagonals. That's only the rhombus because a kite's not a parallelogram. All right, so here's just some other ways to prove figures are rectangles, rhombuses, and square, or I guess rhombi and squares. All right, so now let's do some problems. This is the only page I'm going to do. This is the last page for this particular lesson. A modern artist sculpture has rectangular faces. The face shown here is 9 feet long, and that's marked in the diagram, and 4 feet wide, and that's also marked in the diagram. Find each measure in simplest radical form. Oh, what a good review of Pythagorean theorem, something that you will need. All right, so DC, remember something that's true about rectangles is it's a type of parallelogram, so opposite sides are congruent. Right, and that's because it's a p-gram. I'm going to abbreviate parallelogram because I don't have too much space. So if this side, if AB is 9, DC is also 9 feet. And then all of these, this is one problem. So all these numbers go together. So, I mean, it's 4 problems, yes, but all of the information remains constant. So it's not, notice those, that 9 feet and 4 feet are on the diagram. So I don't have to worry about erasing. AD, right, so same thing as number 4 here, right? So this reason here, opposite sides of a parallelogram are congruent, applies to number 1 and number 4, finding DC, and number 5, finding AD. So this is also 4 feet. DB. And so you can tell this was a whiteboard practice. I have a little asterisk here that says show your work. Well, I will show my work, I promise. DB, all right, so that is, I'm going to outline that in yellow, because if I outline it in black, you'll never see it. All right, so that's that side right there. And by the way, this is very similar to a homework problem, so pay attention. All right, so I'm going to write that. It's very, very similar to a homework problem. So it's not itself is not a homework problem, but it's similar to one. All right, so notice that this is a rectangle, and something we know about rectangles is they have 4 right angles. So if we look at the 2 sides and the diagonal together, they make a right triangle. And in a right triangle, you can solve for a missing side, because we're only missing one side, right? We're just missing DB here. You can solve for a missing side in a right triangle using Pythagorean theorem. Right? That would be that's your best way. That's the only way you get an exact answer. And anyway, I don't know any angle measure, so there's no way you can use a trig ratio. So 9 squared, so important, that's leg squared plus leg squared equals hypotenuse squared. How do we know that DB is the hypotenuse? It's opposite the right angle, of course, right? That's the hypotenuse. So 9 squared is, oops, I gotta go back to black. Otherwise, you can't see it. 81 plus 16 equals x squared. If we add that together, that would be 97 equals x squared. Right? So a little practice with Pythagorean theorem, no practice with simplifying, however, because that is a prime number. So its only factors are 1 and 97. So dB here is the square root of 97. All right, so that one is done. How about AE? AE. So remember that this is that a rectangle has congruent diagonals. I'm going to get rid of the show your work. Right? I promise to show my. Oh no, I can't. It's locked in there, I guess. That's all right. So diagonals in a rectangle are congruent. So I'm going to put rectangle has congruent and bisected diagonals, right? It's bisected because it's a type of parallelogram, and they're congruent because that's a feature of a rectangle, right? So that means that all of these are the exact same length, and I don't know if you can see that, so I'll use that handy dandy fancy yellow again. All of these are the exact same length, right? And the diagonals are bisected. Right? So that means, so we found the measure of BD. If we take half of BD, what would half of the square root of 97 be? Well, this half of the square root of 97 would be 1/2 times the square root of 97. So AE here is the same length as EB, for instance. Oh, got to go back to... And EB is just half of the square root of 97. Or we can write it like this. We can put 1/2 in front of the square root of 97, or we can, we don't really need that 1 in front, right? Because 1 times anything is still that same thing. We can just put the 2 underneath the square root of 97. And there we go, right? So Really, not a whole lot of work that I needed to show there. I just showed you it was congruent to that these diagonals were bisected and they are congruent. VWXY is a rhombus. Find each measure. All right, so that's in that picture over there, diagram over there. All right, so TV, want to find TV. And that's this length here. All right, well, we don't have anything marked there, but that's okay. This is a rhombus. We know a rhombus has 4 congruent sides. So every one of these is the exact same measure. Also, by the way, this is also similar to a homework problem. All right, so if I find the measure of WV or XT, it's going to be the exact same thing as TV. Right? So since the diagonals are congruent, we'll set it equal to one another. So 3b plus 4 equals 13b minus 9. Subtract 3b from both sides. You get 4 equals 10b minus 9. Add 9 to both sides. So you got 13 equals 10b. And if you divide by 10, I don't care if you make it a fraction or a decimal. This is a terminating decimal. B is 1.3. Now, we're not done because we weren't asked to solve for B. We were asked to find the measure of TV. So just plug it into any one of those. It doesn't make any difference. Right? So I'll plug it into the, and actually I think I'm going to go with I'll put it like this, 10/3 or 1.3. It'll be easier for me to work with the 10/3. So TV equals, let's plug it into the 3b, because that's gonna simplify nicely. So 3 times 10/3 plus 4. Man, I guess I should have moved some of the problems. Woo! All right, so that's the 3 times 10/3 is the same as 30/3, or just 10. And 10 plus 4 equals 14. So TV here equals 14. Yeah, I'm going to put a little box around it. Help it stand out. That's where I'm writing right now. All right, so now, and I'm going to work over next to the diagram because I'm out of space there. Let's find the measure of angle VTZ. So VTZ is this angle right here. All right, so remember a rhombus, I'm not going to write down the, maybe I can write it over here. But rhombus, remember, has the diagonals bisect the angles. Right? So that means that this one is congruent to this one, is congruent to this one, is congruent to this one. This one's congruent to this one is congruent to this one. Right? But we don't have a whole lot of information here about the angles. Right? Something else that is true is that the consecutive angles are supplementary, because this is a parallelogram. And consecutive angles are sup, because it's a parallelogram. All right, so now let's see if we have enough. Let's see, we actually do not right now have enough. However, we could get enough if we knew what A was, right? If we knew what A was, we can just plug it in. How can we find A? Well, we could answer question number 10 first, because that's just this angle right here. And we know the diagonals are perpendicular to one another in a rhombus. And so that angle there is 90 degrees. So since I don't have enough information about any other angle, we could use the only angle I know anything about, and that is the fact that 14a plus 20 is equal to 90. So now we can just solve for A. So if we subtract 20 from both sides, we have 14a equals 70. Oh, it's going to go in nicely. Divide both sides by 14, and a is equal to 5. So now that we know that what a is equal to, we can find our missing angle. Sorry, number 10 has nothing to do with that missing, but the diagonal with the finding the measure of a here. I didn't look at it very carefully, but we were still going to need to find it anyhow. And we will use the information I wrote that the diagonals bisect the angle and consecutive angles are supplementary to find the last part. But for either of those two, we had to find out what a is. So now that we know a is 5, we know that angle VZT is equal to 5 times 5 minus 5. That's 25 minus 5. That's 20 degrees. The other angle we're looking for, I'll write in a different color, is VTZ. V, so it starts here. Didn't I do? I did VZT. Oh, I'm sorry. VZT was the one I'm supposed to look for first. This was number 9. So number 9 is the 90 degrees. So the measure of angle VZT, is 90 degrees. I mixed up my Z's and my T's. The measure of angle VTZ is, and once we know what A is just equal to 20 degrees. And we're all done with this one. This one was the hardest problem so far, and that's only because I think I don't have that much space up here. The last thing we're going to do is find the missing measures if EFGH is a square, and we're going to use simplest radical form. All right, I think some of these are going to be pretty easy. All right, so we're given HM is 4. Diagonals are bisected in a parallelogram, and a square is a type of parallelogram. That means MF is 4, and that means HF is 8. HE. All right, so HE, we're looking for our missing side here. We don't have too much information except this is a square. So not only the diagonals bisected, because it's a rectangle, this is also 4 and 4. Because this is a square, the diagonals are perpendicular. Oh, look at that. We got a right angle. Where's the hypotenuse? It's right there. So we can solve for HE by doing 4 squared plus 4 squared equals x squared. So that would be 16 plus 16 equals x squared. And that would be 32 equals x squared. This one will simplify. So HE is x is the square root of 32. A factor of 32, this is 2 times 16. 16 is a perfect square. Ooh, hope you can see this. 1 4 comes out, 1 4 goes away. I could probably extend the board a little bit. Maybe not. Oh, I'm almost done anyway. So HE is 4 square roots of 2. Right? 1 4 comes out, 1 4 goes away, and the 2 has nobody. It's all alone. So it stays in radical prison. And then the measure of angle EMH. So that is this angle here, EMH. We just said that when we marked that the diagonals are perpendicular, 90 degrees. And finally, the measure of MEF. So that would be MEF. That's this angle here, right? All of these angles are right angles, because it's a rectangle. A square is a type of rectangle, and because a square is a type of rhombus, the diagonals bisect the opposite angles. So this angle MEF is just half of 90 degrees, which is 45 degrees. All right, one final little thing. Right, is I just want to go over the features of the rectangle, the rhombus, and the square. Right? If you have any questions, let me know. I can go over it with you or do it a little slower. Right? Last page. The following are the properties of the diagonals of a special quadrilateral. So we saw a lot of using diagonals here when we were looking at proving rectangle, square, and rhombus, right? Figuring out the measurements. Right? So the diagonals of a rectangle are congruent because a square is a type of rectangle. Diagonals of a square are congruent. The diagonals of a square are perpendicular. Diagonals of the rhombus are also perpendicular, and because a square is a type of rhombus, the diagonals of a square are perpendicular. The diagonals of a rhombus bisect each pair of opposite angles, and because a square is a type of rhombus, each diagonal of a square also bisects a pair of opposite angles. Right? So any feature of a rectangle or rhombus is also true for the square. All right, this is the end of special parallelograms. Thanks for watching. Bye for now.